Hello, and welcome to University of Hertfordshire, School of Engineering and Computer Science. I'm Behrad Vahedi, BSc Programme Leader for Automotive and Motorsport Technology. Unfortunately, due to the current situation, we cannot host you here at the university. However, I'll be going through a presentation for the next half an hour or so, which covers the type of courses, teaching facilities, and the special projects we have within the automotive division. So, as far as the courses are concerned, we offer three types of undergraduate courses within engineering department. The very first one is a BEng or a Bachelor of Engineering, and that is a traditional engineering program. And the assumptions are that students are joining us with a good background in maths and physics because they will be taught further maths and physics within the modules that they are taught as part of the degree they do with us. The second program that we offer, it's a Bachelor of Science in Engineering. It's a different approach to engineering altogether. It is a practical course, and we have less maths and physics within the course itself. However, students are taught the applications of maths and physics for engineering. Also, they are taught a lot of computer-aided engineering tools and what is expected from industry for them to know when they want to join the industry. And the third one that we offer, it's an MEng program, which is a Master of Engineering, and that is an extended engineering program, and that is an extended undergraduate course. The course is designed in such a way that the additional year gives the students the skills required for leadership within engineering. And that puts them a step ahead of those that they only have a Bachelor of Engineering degree. Now, looking at the structure of the programs that we offer here, the structure for the MEng, BEng, and BSc programs are very much similar, but they are different in terms of the contents of the program. What we offer for our students, we offer what we call a year zero or an initial year, and that is specifically for those that they would like to join a Bachelor of Engineering or Bachelor of Science program. However, they may not have the exact requirements for entry. And we have a number of partner colleges that they work with us, and we offer a foundation program or a year zero program, and students are taught partially at the colleges and partially at the university, and that year makes them ready to join the first year of the engineering program. The very first year of the program, it is designed in such a way that the students, they do have modules which are very much about their own discipline, but the rest of the modules are the fundamentals of engineering, and they are shared amongst all the engineering programs. As it goes to the second year, that's the year that the modules become more and more specific to the discipline that they are being taught on, being it automotive, being it aerospace, or mechanical engineering. The third year is an optional year for all the students, and that's the time that we encourage all our students to take a year out and go and work for industry. And the university supports the students heavily for that year to happen. What I mean by that is that we have a dedicated team that they are working with the students to help them find opportunities out there, help them with their CVs, help them to prepare themselves for interviews, and so on and so forth. And it is extremely important for our students to take the opportunity and go out there and work for industry for a year, because that additional year in the middle gives them the understanding of the industry, gives them the ability to learn the skills which are out there related to their discipline. And by the time they come back to do their final year with us, they are of a completely different level of understanding of what is expected from a graduate engineer out there. And that helps them do so much better in the final year. And also, by the time they do the additional sandwich year and do their final year, they are in a position that they become a graduate engineer with 1 year work experience. And that helps them find a job so much easier. So we encourage all our students to go out and try to do a year's worth of placement out there. And that helps them a lot in terms of the future of their career. Then after that, we have the final year, and the final year, the majority of the modules, if not all, are all focused on the discipline which is related to their degree, and that's the year that they have their dissertation as well. Those are students that they are on the BEng pathway. If they have the right qualification in terms of the grades, they can apply to go on the MEng program, and that is normally done at the latest by the beginning of the final year that they are with us, which is the level 4. And at that point, they can, if they have the correct or the right amount of grades, they can go on the MEng pathway. We have a similar structure for the BSc program. So we do offer the year 0, the foundation for them, and then they have the first year, they have the second year, and then they have the option to go out and do the placement program, and then come back and do the final year. The only difference here is that the BSc students cannot join the MEng program. However, should they wish to do a master's degree, they can do an MSc, which is a postgraduate program. And the MSc is open, of course, to the BEng students as well. In terms of the options that the students have as a degree within the BSc program, we offer 2 different programs, and one of them is Motorsport Technology with Management, and the other one is Automotive Technology with Management. The major difference between the two is that, as the name suggests for the very first one, the topics are more focused towards performance vehicles, and the second one covers the mainstream automotive industry. And the very same applies to the automotive degrees as a BEng or MEng program. We have automotive engineering, and we have automotive engineering with motorsport. And again, one is more focused towards the mainstream industry, and the other one is more focused towards performance vehicles. Now, as far as the automotive teaching facilities and laboratories are concerned, on this slide you would find a number of laboratories as well as equipments listed here, and I'm going to go through them in details within the next slides or so. And also you can see that we have a number of standard equipments, and these are specialized equipments which are used by industry out there, and we have them here at the University of Hertfordshire. And also we have a number of laboratories that the students are making use of them to carry out their special projects related to the discipline. So the very first test rig that I'm going to talk about is a test rig which is unique to the University of Hertfordshire, and it's a 4-post shaker. And a 4-post shaker, which is the one that you see in the picture, is a pre-production test facility and a post-production test facility which is used by industry out there. Companies out there, the likes of Jaguar Land Rover, they have 3 of them. Ford apparently has got 1 or 2 of them. Bentley has got 1 of these. Rolls-Royce has got 1 of these. And University of Hertfordshire has got 1 of these in here. The way the equipment is used in industry, during the prototyping period, when a vehicle is introduced to a new set of suspension, they need to test the vehicle to see how the car itself behaves in terms of damping the vibration coming from the road, and see how the suspension behaves. And they put it on top of the 4-post shaker, and what it has it has 4 actuators, and each actuator applies a certain amount of vibration to each wheel, and that mimics what we call a roadmap. Based on the roadmap applied to the car, the suspension should behave and dampen the vibration, and also should keep the car in balance. And that is observed and monitored and calculated to make sure that it is doing the job correctly. In terms of the cars being tested while they are coming out of the production line, which is known as a post-production test rig, car companies, they are the ones that they are producing a sheer number of cars. They do a sample test. So for instance, one in every 10 cars coming out would go on top of the test rig. It is tested for 90 seconds, and then if it passes, it comes out. The likes of Rolls-Royce and Bentley, every single car coming out of their production line, it goes on one of the test rigs that you can see in here. It is tested again, and then if it passed, then it goes out. We make use of the facility as a teaching aid for vehicle dynamics modules, and that is used for our students to understand the relation between what is taught to them as a theory and also what is taught to them to use a simulation package to understand how the suspension works and compare that with a real result that they get from the test rig. Also, we have rolling road facilities, and that is one of the facilities we have, the one that you can see in the image in here. And we have a dedicated vehicle, which is our engine mapping laboratory, and it is a mobile laboratory, if you like. And the vehicle is equipped in such a way that students sit inside the car with the instructor, and that would be the chance for students to see how the engine is mapped live, and they can understand how the parameters of the engine can be changed to increase or decrease the performance of the engine, and also they can observe the emission of the engine, they can also observe the performance of the engine, and also they can see how these parameters will have an impact on the vehicle performance itself. Also, the rolling road is used for our own special projects. I will be talking about projects similar to Formula Student, VX220, so on and so forth. These are the projects that our students, they develop their own powertrain for the vehicles. Once those powertrains are developed or modified for those vehicles, they need to be mapped again. They need to be tuned and mapped with the new setup. And that is the time that actually students get a chance to help with the mapping of the engine, and also that is the time that they get an opportunity to understand how the mapping of a newly developed powertrain is done within the university. So that helps them really understand the concept of development of powertrain. The other equipment we have within the automotive division, it's a Cruden F1 simulator, which is a 6 degree of freedom simulator, and it's a driving simulator which is used as part of our teaching aid for certain modules. Also, it is used by the racing team of the university, and it helps them understand how they should behave around the track, and also how to train themselves with certain tracks, because they can change the tracks, they can change the vehicle, so they can understand how they can perform better as a driver for the vehicle. But the main purpose of the simulator for us is using it as a teaching aid for certain modules, and the students are being assessed on that simulator as part of the vehicle dynamics modules as well. So it is a teaching aid rather than just being a driving simulator for fun. Now, I would like to talk to you about a special project that we run here at the University of Hertfordshire. And the very first one that we are very proud of is the Formula Student project. The Formula Student project is a design project initiated by the Institution of Mechanical Engineers, And University of Hertfordshire has got a long-standing history with Formula students. This year, our students were building UH23 because the project had to come to standstill because of the current situation. But UH23 was being built by our students up until almost a few weeks ago. And that shows you the number of years that we've been attending the Formula student events. The project is run in such a way that every year students build a car from the scratch, and that starts around October time. And by April, they have a fully built vehicle ready for testing. And the way it works, the current students, the ones that they were building UH23, they were designing UH24 for the next students that they would come in. That would enable the next students to have a design ready to be built, and then they would start working on UH25, so on and so forth. These cars are completely built and manufactured by our students, and it becomes part of their life. And to some extent, it becomes their life during their final year. And also, if they want to join the program as early as their first or second year, they can be part of it as a member of the team, and then they can just build their experience. And by the time that they get to their final year or to their master's year, they will do a project on the vehicle. So that becomes part of their curriculum, if you like. We have normally a group of 25 to 30 students working on a car within that year, and each of them would have one specific part of the vehicle to work with, and that allows them to understand and develop that part of the car itself. The cars that is shown in the picture, especially the one at the bottom, that is UH22, and that is the last year's vehicle. The one at the top is UH21. And 22 was the very last vehicle, which was using an internal combustion engine. From this year onwards, the university has decided to move towards a different direction altogether, and that is the project, and the has now moved towards a direction of fully electric vehicle. So UH23, it will be one of the car. I mean, it is not actually the very first car that UH has made in terms of being it an electric vehicle, because many years ago, University of Hertfordshire built another electric vehicle. But back then, the battery packages and battery systems, they were not as advanced. Therefore, the weight of them, they were quite immense. As a result of that, it was not viable at the time to continue with that. But now with the advancement of the technology, we are now completely back towards the direction of electric powertrain. And these cars, they go for a competition, or generally for a number of competitions, once they are completed by the end of the academic year. UH22 went last year to the Netherlands first, then it came back, then it went to Silverstone, and then the last competition it went to Italy. So the competitions are international competitions, and these cars are competing against each other at various stages, and they have different events that they have to fulfill in terms of going through all the stages. For instance, they have a business event, they have static events, they have dynamic events, they have endurance events, they have sprint events, so on and so forth. So there are so many criteria for students that they have to be fulfilled in terms of going up the ladder for the competition. But also that allows students to understand a complete process as how a component or a car itself needs to be built, or in fact it needs to be designed, developed, tested, and then built so it can pass all the criteria. The next project, or the next special project that I would like to talk to you about. It's called VX220 Racing Car. Here at UH, we used to have a number of Vauxhall VX220s, and at some point it was decided to turn one of those cars into a racing vehicle. So the car on the left was one of the old cars that we had, and that was stripped down completely. And in a window of one academic year, if you like, the car was turned into what you see on the right-hand side. The car has been redesigned and redeveloped in many ways, and the majority of the components, they were completely changed, and that was all done by our students. So students, as part of their dissertation or their final year project, they worked on the vehicle in such a way that each of them was given a task for one part of the car itself, and they had to go back, they had to do full engineering analysis on that component to understand what is the new requirements, what are the new expectations from the car itself, how they can change the performance of the vehicle if they were working, let's say, on body parts. What were the chances of reducing weight while maintaining the integrity of the components, and so on and so forth. And by the time they finished it, they had a fully built vehicle and the car at the moment. And ever since, there have been students working on the car, trying to improve the previous design and try to get it even do better. The car has never been raced in its own sense, but it is aimed to be out at some point. And unfortunately, this year was the year that it was going to go out for a shakedown, but unfortunately, due to the current situation, there is not a chance to take it out for a shakedown. The other project that we have within the division, and just something to add here, when I say within the division, none of these projects are aimed purely for automotive students. These are out there to cater for all the students, anyone who would like to join the team. And normally within each of these teams, we have students coming from different disciplines. We have students coming from the aerospace program. We have students joining us from electrical program. We have students joining us from mechanical program. So these are not just for automotive, these are for all the students or those who are interested in these projects. The other project that we started working on that a few years back, it's called Shell Eco Marathon. And this is while it is assumed that this is not for petrol heads, the reality is this is a pure engineering project. The students are meant to produce a car that can go as far as possible with 4 liters of fuel. So it's all about reduction of weight, reduction of rolling resistance, reduction of drag of the vehicle, so in terms of the aerodynamics of the car, and also learning driving strategies as how they can coast and also make use of the powertrain to let the car go. And the car, you can see in the picture, managed to do 500 miles with 4 liters of fuel. So it's all about optimization. It's all about making use of what's available to get the best out of it. So this is a pure engineering project in my view, because that enables the students to work with a lot of restrictions and limitations and still try to get the most out of it. So they have to minimize the amount of material used, they have to minimize the amount of components used for the vehicle, because if they can reduce the number of components, they can reduce the amount of mechanical losses. Also, they can reduce the amount of weight. So that should help them to go a bit further with the power available to them. Also, they need to understand a lot of strategies about driving and also how to make use of the vehicle itself and its weight to let the car coast rather than relying on the powertrain at all time. The last special project which started last year is the UH Formula 1000 Rally. UH at the moment aims to develop its own rally car which can compete within the Formula 1000 Rally Championship. And there are a number of students working on the vehicle itself at the moment, and they are working on certain areas of, let's say, air intake, exhaust system, and also improvement of the certain parts of the structure in terms of the attachments of components to the body in white of the vehicle, because the vehicles are just standard city cars. They are only allowed to make use of vehicles the likes of Citroen C1 or Toyota Aygo, which are very similar cars, if not identical, and these are meant to be just a city car rather than a rally car. Again, the project is very much limited by the organizers, so they do not allow a lot of changes in many areas. For instance, the powertrain itself cannot be changed. By regulations, they cannot change that at all. However, in terms of the air intake system, they are free to change that completely. So they can improve performance of the engine if they can change the air intake of the vehicle and also the amount of air taken in. And also in terms of the exhaust system, again, they are not very much limited. They can do whatever they want to do if they think that is going to improve the performance of the vehicle. As a result of that, students are working with a certain amount of limitation, and also they are aiming for a better performance of that vehicle. So to see what are the limitations, what are the new expectations from the car, and how they can make the car perform slightly better than the other competitors out there, and of course to make the car work much better. Thank you very much for your time. Just before I end the presentation here, I would like to mention to you that we have very good industrial links out there with the automotive industries. And the industry has a very good understanding of the quality of our graduates. As a result of that, we have a very good employment rate. Just within the School of Engineering, our employment rate last year was 86%, which means that 86% of our students, they managed to secure a job within the discipline, and that was job secured within 6 months of their graduation. Also, as a result of that, we managed to secure a lot of placement opportunities for our students, and that is the time that we encourage them again to go out, find their placement opportunities, and do work for them. And one last thing to say in here is that if someone is graduated with a degree in automotive engineering, that does not necessarily mean that they are just very much limited to jobs within the world of automotive. We have automotive graduates that they got a job in defense area, especially aerospace defense. And sky's the limit for them. We have automotive graduates that they got jobs in marine industry. At the end of the day, these graduates, as long as they have the right set of skills, they become employable by any employer out there, and sky's the limit. So all these different types of engineering is all about the passion of the applicant and who wants to do the course. So they are not going to be limited within this discipline, and they can go anywhere and do any sort of job elsewhere. I'd like to thank you all very much for this and listening to me. And if you have any questions, please do come back to us, and we hope to see you soon. Thank you, and bye-bye.